Google is buying 7 nuclear power plants to power their AI solutions.
That's a lot of power. You don't need that much power for all type of AI. There are ways to reduce AI into much smaller, much low power devices. Let's see how we can do that. Today, we are going to use a small Raspberry Pi to generate certain events such as movements and then feed them into a tool called Edge Impulse. Edge Impulse will shrink that down to a smaller AI model, which then can feed into an edge device that can run that AI model without connecting to a cloud.
Once you create an account, the first thing you need to do is connecting your edge device to Edge Impulse. In our Raspberry Pi, we have installed Edge Impulse libraries and run Edge Impulse Linux command to do this. Once the connection is set, we move back into the Edge Impulse website and start sampling movements data coming from the accelerometer attached to the Raspberry Pi. We need a good number of movement data from the accelerometer in order to make the AI model work. Once a sufficient amount of data collected, we are creating an impulse. Impulse is how you process this collected data. As a part of that, first we add a spectral analysis to analyze the features of the incoming movements, and then we add a classification block and an anomaly detection block in order to classify them and isolate anomalies. Once done setting up an impulse, the next thing is to identify the features out of the data collected. So in Edge Impulse, when you click on Generate Features button, it goes through all the sampled data to identify unique patterns within it and then classify them in different categories so the AI model can be trained using those data. Your feature generation is successful if you see clearly segregated clusters of features just like this one. You can click on any of those data points to identify where they were taken from the original sample, and you can modify them or exclude them from the final AI model. Alright, it's time to train the AI model. 20% of the data you set aside for testing later on, but you take the rest of the data and run them through the training to train your final AI model. This training may take a couple of minutes to complete, but once completed, you will see how successful your training using one of these confusion tables. Looks like our training went very well. The data is well segregated and there are less confusion. Now it's time to train the anomaly detection part. We select X, Y and Z axis RMS data to detect anomalies. This will take a couple of minutes like the previous one, and once completed, you will see a graph segregating data points in non-overlapping clusters. Final step, let's compile all of this and upload into the Raspberry Pi. Let's see how all of this works in the Raspberry Pi itself. We are making a couple of movements left to right here and up and down, and couple of circles. Raspberry Pi captures these movements, send them through the AI model, and the final classifications will be sent back to the website. As you can see here, all left-right movements are correctly identified. Similarly, the circular motions over here, as well as the up and down motions, are properly categorized.
That's the beauty of Edge AI. If you have any questions around Edge AI or you need to build your own solution with us, drop us a note. Thank you.